Hi everyone, my name is Nitin Krishnaswamy, and I'm going to be talking about my November project, which is a dog GAN. What are some of the elements that we used in my project? Well, what is my project in the first place? I designed a system that is supposed to generate realistic looking of dogs using a machine learning techniques. The technology that we used was called a GAN. And we used Python as the programming language, along with libraries such as NumPy, TensorFlow, and Keras. Our entire program is based off of two machine learning algorithms: unsupervised learning, which is our generator, and supervised learning, which is our discriminator. I'm going to be talking about those two things later on. Our training data set was 20,000 images of dogs, which we imported from Kaggle. So what is a GAN in the first place? It stands for Generative Adversarial Network, and it has two neural networks. One is the generator, and one is a discriminator. As I said earlier, the generator is unsupervised learning, and the discriminator is a supervised learning. The generator's job is to create an image of a dog, and the discriminator's job is to tell if that generator created a realistic looking image or not. So it decides if it's fake or not. The generator is the creator, discriminator is an identifier or classifier. Now I'm going to be talking about what supervised learning is. It's when you have a machine learning algorithm that creates outputs that are similar to what it was provided. For example, if the algorithm is provided with house prices, like it was a chart, where at a certain time, the house price was this high. What the algorithm would do is it would receive an input, and based on that chart that it received as a test case, it will create more outputs that are similar to that. This is the discriminator because all it does is create true or false. It's classifying the images that it receives from a generator. Now I'm going to be talking about what unsupervised learning is. This is when the algorithm isn't provided with any labels that to reference for the images that it receives. So it has to form its own conclusions and structure from the data. This is our generator. All it's doing is creating completely random image and sending it off to the discriminator. It doesn't know what it's creating. It doesn't have anything to go based off of either. This is for when you're creating something that is not based off of anything else. So now I'm going to be talking about the actual element of the GAN. So what is a generator? A generator, as I said earlier, is an unsupervised model. It has to create a completely random image to fool the discriminator. So what it does is first it starts off from very, very general. So it'll just throw a random blob on the screen. This blob, it'll send it off to the discriminator. Because at the very beginning, the program isn't very smart. It's going to create a completely random image, like probably that's blank. We're going to call that noise. At the very beginning, it has nothing to go off of, so it's just going to be some blank screen. It'll send that off to the discriminator. Based on that, it'll receive some feedback. So this is when it'll start to learn a little bit. This is also when the layers start to come into play. It starts off, like I said, really general. So it'll throw a random blob on the screen. Then as it goes down through the multiple different layers, it'll start to get more advanced. So at the beginning, not advanced at all, random stuff. But as you go down, it'll start to add like a few more features. So at the beginning, it might do just the background is blue. Then it might do, oh, now there's a body. And then it'll say the paws. And then at the very last stage, it'll do fur and maybe the eyes. So that's how a generator works. So this is a sample of some of the code that we're using. Now, the discriminator is what receives it from the generator. This is a type of neural network. It's a convolutional neural network. What a convolutional neural network means is that it receives, before sending it off to the deep learning network, it'll start to organize the order of importance of the information that it receives. So when it receives an image of a dog from the generator, it won't send it to the discriminator right away. What it'll do is it'll look at each element of the image of the dog, and it'll say what's the most important and what the discriminator should look at first versus what the discriminator should look at last. So it might think that the eyes and the face of the dog are more important than maybe the grass in the background. The discriminator is going to be placing the image of the dog from the generator into two categories, which is a real category and a fake category. This is a process that is also known as classification. Like the generator, the discriminator works on multiple layers. But this time, instead of from very general to very specific, the discriminator is going to be working backwards. It's going to be receiving a specific image from the generator, so it's going to go from specific to general. So at the very beginning, the discriminator is probably going to look pixel by pixel at all the images of the entire image. It's going to find, based on the training data set that it received, so it received 20,000 images in the beginning, which I told you at the very beginning of the slideshow. 20,000 images imported from Kaggle. Off of those 20,000 images, it's going to train. It's going to refine the parameters that it has and decide how to sort from real and fake. So for this generator, it's going to compare it to the parameters that it's using. And after that, this is a very specific level. Now it's going to move to more general. So now it'll maybe look at if there's a body, if there's a head, and then it'll decide real or fake. This is a sample of the code for the discriminator. This is just one of the layers. Now we're going to talk about how the program actually improves itself. This is something that we call loss. So the discriminator and the generator have no way of knowing how well they're doing if not for loss. So loss tells them if the code that they're changing or the parameters that they're changing is improving how it's interacting with the discriminator and the generator. So what does that mean? So the loss, it works in two directions. It goes higher or lower. For the discriminator, I'm going to start off with the discriminator first. For the discriminator, the higher the loss, the worse it is. This is the same for both the generator and the discriminator. So there's losses determined with real loss and fake loss for the discriminator. Real loss determines how many photos it found was real. Fake loss is how many it found was fake. If the discriminator starts to get more and more images wrong, loss will go up. This is because the program will start to know that discriminator is not learning at all. All it's doing is saying the same thing over and over again, and it's getting it wrong continuously. This means the changes that it's made to its parameters haven't made any effective change to how it determines if it's real or fake. The generator only has one type of loss. It's if it fooled the discriminator or not. The loss for the generator will also start to go up if it's not fooling the discriminator at all. This tells the generator that it needs to change the way it thinks and start to develop a different type of image to try and fool the discriminator a different way. So loss is the way to improve the program. So here are some of the outputs that came from the generator and the GAN. So it has to come in a form of a grid of 16 images. So every epoch that it runs. So an epoch tells you how many times your program is going to output something. So if we have like 500 epochs, it's going to output 500 of these type files. So the files are 16 images that are formed in a grid, and each image is 64 by 64 pixels. In the beginning, the outputs won't look very nice. This is because the generator and the discriminator are just starting to learn. So the generator and the discriminator will both be very Stupid is actually a good word for it. They won't know how to develop a proper looking image, and the discriminator won't know how to properly distinguish it. So this is why at the very beginning, it might just be like a gray screen. However, as time goes, it'll start to look a little nicer. Here is on epoch 600. It's still not very like dog-like, but it looks a lot nicer. You can see some of the resemblance. So a few of these might just be a head, some of these might just be the body. This is demonstrating how a GAN evolves. It won't just stay very low quality. It'll start to get better. So if we continue to run our GAN, it'll definitely produce better outputs. So what did I learn? I learned how to use TensorFlow, which is one of the libraries that we use in our program. So first I'm going to tell you what tensors are. A tensor is a way to hold images. So it's you tell it 64 by 64 pixels and how many images. It allows you to quickly zoom out of a neural network and only look at it in small sections. Instead of having to focus on each individual tensor, now you just have to focus on the outer one. Think of a tensor as a file, and the filing cabinet is TensorFlow. You just have to focus on the outer image to TensorFlow. Next, I learned that computers aren't very good at drawing. I'm on epoch like 800 right now, and it still doesn't look very dog-like. If we, as humans, did 800 images, we would probably have nice images, really nice looking dogs. This computer is running at a much slower rate. However, these computers have something else, which is a lot more stamina than a human, and patience. Humans wouldn't want to sit and look through 20,000 images of dogs and try to create a realistic looking image. They just simply don't have the time or patience to do that. They'll give up after maybe like 100. Computers can do the whole thing and more and create images on that too. Thousands of them if they so please. So one of the challenges that we also faced is creating an efficient program that is capable of improving itself. It's a lot harder than it seems because we have to create a program that not only prints out an image of a dog, it has to create a better image of a dog every single time. It can't just go down or stay neutral or just flatline. It has to go up, or even if it goes down, you'll know that it's improving or it's changing the way that it looks at things. Finally, the last challenge that we faced, or the last one that's big, is writing a function that are dependent on each other. Our entire program is based off of generators, discriminators, and loss. If any one of those failed, our entire program wouldn't work. So we have to create every piece of our code has to be correct in order for our program to run effectively. So what are some of the uses of a GAN? While a GAN itself, the entirety of it is a research. It's not used in actual companies, but elements inside of a GAN are used in many different fields, like the discriminator and the generator are used. Clearly, GANs are very important. If not to create it, you should learn about it so that you can create a lot of different ideas in the future.